Hello, everybody. Welcome to another exciting episode of JavaScript Jabber. I am Steve Edwards, the host with the face for radio, as you can see, even the voice for being a mime, but I'm still your host. With me today on the panel, we have Mr. Dan Shapir coming live from Tel Aviv, Israel. How are you doing, Dan?
Well, it's hot here. Surprise, surprise.
Yeah, we're going back and forth here. It was pretty warm last couple weeks, and now it's a little cool and cloudy, and it's going to be pretty mellow, so pretty nice. We're getting into the end of August.
Good for you.
I'm going to let Dan introduce our special returning guests. So go for it, Dan.
Yeah, so I'm really excited about today's guests. We have two of them, which means it's double the pleasure. And they are both a living testament to the fact that you don't need to work at Google or at Meta or at some other FANG in order to make a huge impact on web development. So we have Ryan Carniato, and we have Tanner Linsley. Hi, guys. Want to introduce yourselves in case somebody somehow doesn't know who you are?
Oops, sorry, I got to hit the pause here. There we go. Okay, I got to get that crowd to control themselves.
Lots of fun. Hi, I'm Ryan Carniato. Probably most known for creating SolidJS and my work on Signals.
CEO of Signals.
I'm Tanner. I'm the TanStack guy.
And for those who don't happen to know, TanStack is also where React Query came from, now TanStack Query.
Right. React Query. I still call it that, which is fine.
And also lots of other great tools. You've recently introduced a couple.
Yeah, we have just a couple. We're working on a new framework inspired by Solid Start called TanStack Start. We have a router. We have a new library called Pacer, which is about like debouncing, throttling, rate limiting stuff.
Cool.
We have the controversial name TanStack DB, which is a reactive client store. I mean, it's a database, but it's only for like the client on the front end. It's pretty sweet.
It's a database, except that it isn't, right?
Yeah, it's an awesome library. That's all you need to know. And we've got like table and form as well, virtual. We've got a couple. We're even working on something called TanStack Dev Tools right now, which is
I've heard about that. We will have to bring either you or somebody else from the team on to talk about that when you guys are ready. And I have to also mention create TanStack Start or whatever Jack is calling it these days.
Whatever we're going to call it. It might even just be called Create TanStack, something like that.
For those of you who don't know what that is, we actually had Jack Harrington on the show to talk about it. It's an awesome replacement for Create React App.
At least. Yeah. We got some fun plans for it. So
cool. What's TanStack Ranger? I'm looking at all these.
Ranger is kind of a throwback to my old open source days. I needed a library to do multi-range inputs. So like sliders with multiple handles. I made a headless version of it. I called it Ranger, which was kind of fun.
Oh, see, I'm thinking like Park Ranger and Jellystone Park, and for those
Power
of you
Ranger.
I remember that. So
yeah, it's probably it's the most niche library that we have, which it's cool. I still use it every now and then.
And one more thing about you, Tanner, correct me if I'm wrong, but you've transitioned to work full-time on your open source stack, right?
Yeah, about a year and a half ago.
That is awesome. So basically, you're the guy not making a living so the rest of us can.
I mean, as of 9 months ago, I'm making a good living now. So,
oh, yeah?
So what is your business model for that then?
Well, it's different than most others, I think. So I abhor VC around OSS. I've done venture capital for my last company and I've also bootstrapped plenty of things. I didn't want to do that for TanStack. So TanStack's basically run like a media company right now as like a business side of things. So marketing, advertising, partnership, brand deals, and the like. And that's how TanStack is making money and paying both me and also now contributing a lot towards contributors as well. and that's just going to grow over time.
So
Hopefully.
what does that mean? Running ads within your website, within your products, or something else?
Yeah, so TanStack.com is the revenue generator, and the libraries are just guests on the TanStack.com show every day. if you want to look at it
Cool.
that way.
That's interesting.
Yeah,
I'm really happy that it's working for you.
yeah, it's working so far. So we'll see. I don't know if it's scalable or not, but it works for me, and I think that's good enough for now.
And how about you, Ryan? How are things with you?
Pretty good. I've been at Sentry now for almost a year. So,
okay.
yeah, like this week coming up marks a year at Sentry. So, they've been great. Been able to obviously support my R&D. I've been doing a lot this year because I've been working on a lot of new areas, kind of for upcoming releases of Solid. And they've been supporting in lots of other ways. I've been getting closer with the Syntax FM guys.
I was going to ask if you worked with them. Yeah.
Yeah. So we've been talking about how to up my game on video content and different kinds of media stuff, like better promotion. So
I'm guessing they told you need to make longer videos.
That's funny. No, they were. Everyone's been really stoked on those shorter videos that I've been doing recently. They said they were like a little crunched, could use some more production value. But generally speaking, I usually stream for like 5 hours ish. Maybe every other Friday or so. And I started in the last couple months doing like 10-minute videos. And for me, doing 10-minute videos is very hard. It's condensed. It's like because I picked really deep topics, but I just needed a place to point people to when people are like, signals, blah, 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 like complaints, I'm a React developer. I don't get why they're important. It's just like, okay, well, can I make an FAQ basically as a video? And that's sort of what I've been trying to do. Find content that's short enough that people will not like balk at looking at the like whole like length of the video, but then still get a lot of unique content in there. It's difficult because my expertise is, as I said, very, very deep. You don't really find content like I do in most video content. Like you guys sometimes get really deep on your podcast, which is why I love this podcast. But a lot of video content isn't the same sort of thing. It's either like, how do you do this? Or it's like the most beginner intro level of stuff. So being able to ask the whys, I think is really, really important, and like looking at the design stuff. So I'm going to try and bridge that gap, maybe pick smaller topics that I can actually talk about, in 7 to 10 minutes. So yeah.
You kind of remind me of that. I think it's Mark Twain who said, I didn't have the time to write your short letters, so I wrote you a long one. So yeah, it's definitely much more challenging to create short and concise and to the point content.
Yeah, especially if you spend all your time like really like just kind of exploring ideas and stuff, and taking stuff which way to actually come up to a consolidated message is way more work. I can stream for 5 hours, but then I'm like mostly done. The video is going to take me at least 2 or 3 days,
That's for sure. Well, let's put it this way. I think that once you get the hang of it, you'll be able to do it much more effectively. Maybe you should also consult about it with Theo.
Yeah. He's been waiting for me to like level up that. He was like, yeah, just keep on doing what you're doing, but when it's time, come see me, like better gear, better stuff, so
yeah.
I did one video for View Mastery a couple of years ago, and the amount of work it takes to put together simple videos is crazy, whether it's recording. I would assume that once you get your setup in place, your software and your different hardware components and your speakers and all that stuff, and you know what you're doing, it's probably a lot quicker. But that's got to be a learning curve just in getting set up to do video production like that.
Yeah, and I like editing stuff in. I'm a big fan of Fireship videos, and even my articles are like that. I've always done a lot of meme pictures and like images to back up what I'm saying.
Yes.
To kind of keep it going. Fun. Even my conference talks are like that too. So I find the video editing actually takes me a long time because I need to find just the perfect clip or the perfect image to kind of overlay at the different parts. So like it's like it's almost on like a 20-second cadence. So like it's 20-minute video. That's a lot of clips.
Well, just let AI do it for you.
Well, I have the same struggle with always trying to find the perfect dad joke to publish on a daily basis and to throw in here and there. So I can somewhat empathize.
They're all perfect,
with
Steve.
you.
They're all perfect.
Oh boy, I got to
Right.
tell you some stories about how they're not always, but that's a topic for another time.
Yeah, I think we need to finally get to the crux, to the main issue.
Oh, we had a topic for today.
The main
topic
topic that we're here to discuss.
Gotcha.
So again, I'll give a brief background. A while back, I had this idea of, or let's go even further back. I started noticing a certain pattern that was occurring in a lot of frameworks, especially as they were becoming meta frameworks. And that's and I termed it the comeback of RPC. And we'll talk about what RPC is and why it's making this comeback now. But when I noticed that, it occurred to me that this could be an interesting topic for a conference talk, which I created and already gave once at JS Heroes in Romania. But I reached out to a lot of my friends, people like Ryan, like Tanner, like Rich Harris and others, and and Jack Harrington, whom we mentioned, and started talking with them and about this whole thing. And I realized that a lot of them had very different viewpoints about what RPC is, how it should or should not be used, why it's interesting or maybe not, and what this ended up is this conversation here. I basically asked both Ryan and Tanner if they'd like to come on the show and talk about this. So, take it away, guys.
Yeah, I can start because I feel like this starts with stuff that I was doing. But to be fair, this is stuff that Tanner definitely relates to right off the bat. Because first thing you hit when you are writing a meta framework, like the most obvious thing is actually meta frameworks are centered around routing, right? And the router. And I know this has nothing to do with RPC right off the bat, but like
maybe we should define RPC before we dive into it.
Yeah. Okay. Sure. Remote procedure call. Basically, this idea that you can, in different environments, call a function from the other environment.
Good. I thought it was really popular comedy for a minute. I'm glad we did clarify that.
I like to use a slightly different definition. The way that I like to define it is basically as a method for invoking a service or obtaining data from another process, even on another computer across the network, using a function called paradigm. Are you okay with this definition?
Yes.
So it's basically, it looks like a function call, it feels like a function call. It's as easy to use as and natural to use as a function call, but instead of just actually being a function call, it translates to an operation across the net.
Yeah. The funniest thing is like my first introduction to RPCs didn't feel as easy or natural to use as function calls. I was using SOAP in Microsoft stuff back in the early 2000s. And if anyone's used that, it's like all XML based, and they get categorized under RPC. But that, like, in my head, when someone says RPC, to me, traditionally, that's what I thought of. I thought of these like XML endpoints from like Microsoft server from like 2002 or something.
Well, I'm a bit good memories.
Oh. Yeah, I'm a bit of a history buff. So it's interesting because it was that period in time where RPC was effectively dying. So RPC, the term was coined in the 80s. It became really popular in the 90s with native platforms for it, like Corba or DCOM from Microsoft. And then the web happened, which kind of killed it. SOAP was an attempt to somehow continue to do RPC despite the web, and we can talk about why the web killed RPC for a while at least. And now it's making a comeback in a much more natural way, which is in a lot of ways very reminiscent of how it was in the 90s, but compatible with the modern technologies that we use nowadays.
Right. Yeah. Yeah, I mean, that sounds about right. Like, no one was touching RPC after that early mid 2000s period until maybe like 2020-ish. Like, they're like, at least in the web technology. But I mean, yes, obviously when we start designing these server rendered meta frameworks where we actually have the server and the client being developed in the same place, you start going like, well, if I control both sides, why not like make that pipe easier? But I mean, that was the motivation. The thing for me personally, when I started looking at this stuff, was I was aware of the SOAP stuff, and that, but I was just trying to like, I was looking at other meta frameworks. This is the beginning of SolidStart, like 2021. It was actually before I even released Solid 1.0. And I was like looking at other meta frameworks a bit, and I was looking like Next.js and mostly, and like, Sapper like Nuxt, and they all had these like API endpoints, like where you'd like do this file-based routing system with API endpoints. And and the thing that was weird for me is I used to be a Rails guy for a bit. So like you would define like in the file system, you define, well, I guess not a file system, was an automated file system, but whatever. You'd skeleton out these like models essentially, and API endpoints, and they would describe the whole collection of the whole model of things. And the file system approach that a lot of these APIs had taken was it felt weird to me, because you'd have like a different file for like the general like groups versus like group ID. Like you didn't put all the CRUD commands together. Like it would like separate based on the URL path, not based on the conceptual model. If that makes any sense, like instead of talking about groups as a single thing, you'd have like groups and groups/ID. Like it's a funny thing, but I was looking at these API shapes and I was like, oh, this is such a hassle to like every time I do this to build out these files. I saw Remix. I think this was for me. They did their big reveal in spring 2021, and I know this. And when I saw their loaders and actions and the way that they doubled it up on the API side, I'm like, this is kind of nice. It's like turned into a single approach, because what was kind of awkward was that people would build their app in one folder and then they'd build their API in another folder, and it was getting kind of clunky. You do everything twice, kind of connecting it up. And they were like, no, you can just kind of stick it all in the same place, follow the same kind of pattern. The challenge I had with Remix is because I'd been working on routing for a while, and nested routing, and with parallel data fetching and all these things. Is the Remix loader basically said that this part of the URL loads this data. And that wasn't granular enough for me. I was working on SolidJS, which is based on singles. So as you can imagine, there's multiple different data sources. You want them to update independently, right? You want to be able to refresh them independently. You only want to update certain parts of the page. Treating the whole page like it was like a single data flow was not particularly nice for me. So I was like, okay, can I take my kind of like route loaders, which they're not really loaders, they're isomorphic. They run on both sides. These kind of nested route kind of areas where you can fetch data. And instead of, hitting API calls like we used to, instead of using one single loader, can we make it more ergonomic to define individual pieces of data you can fetch? And I was looking what I was doing on the client side, and I'm like, I love this. I can put, solid query. This is where I get Tanner back in the conversation for a second, but like I can put like my different data fetching things inside this loading, and I can manage them separately. If I'm on this page, I can grab users and their posts and have multiple things, and call them and invalidate them separately. And I'm like, this is a great pattern. It works on the server, works on the client. The only problem is you have to call these extra API endpoints. So I started working on a solution, which was, what if I could use the file system in a nicer way, like better than the API endpoints, where instead of being quite as bulky and like having these URLs, I could use like a proxy or something, like where you could maybe make some types for an object, and based on what path you go through the object, it would construct the URL on the client and then know what endpoint to hit on the server. And I kind of put this together, and I call them actions after Remix's actions. The difference is they weren't really exactly actions. Or they were both actions and loaders. You could basically hit these URLs both on data fetching and on mutation, and you could call them, they're just like auto-generated APIs. And I remember I put that out around April. I made some demos around April 2021, but then Solid 1.0 needed to get released, and I put it aside. And I basically was like showing people and talking about like how cool this was going to be. But, people are just like, oh yeah, whatever, Ryan. And then it was almost a year later. It was
Well, to be fair, half of us often don't understand what you're talking about. So
that's perfectly fair. But some people did, and I was talking to someone in December or like around Christmas time, and they're like, "Oh, isn't that what Blitz.js is?" I'm like, "Blitz? Isn't that the Next.js thing?" And I look at it, and sure enough, that is actually what Blitz was. I basically independently also came up with something similar to what Blitz was, which is
I'm not familiar with Blitz. What is it, or what was it?
It was kind of like a meta framework on top of Next. I thought it was like Redwood. Like it was one of those more opinionated meta frameworks on top of Next. But eventually they just became like a Next plugin and kind of downscaled it. But originally it was like a separate product. Like you wouldn't install Next, you'd install Blitz. And it was a React meta framework essentially. But its cool feature was that it had these basically kind of generated API functions in the same kind of way that I was describing, where you could just kind of put these basically API call things in a file folder structure and then call them directly without like the fetch and the ceremony around like that. You could just call them basically as functions via like a proxy, like I was talking about. Because the cool thing with the proxy approach is you can have the proxy return whatever you want. So it just wraps the details of the fetch away from you. So it is kind of the beginning of this RPC thing, because you still have the API point where you have a file system running telling you like basically where these functions are, but then you could use the path on the proxy, like get users.get or whatever, to actually construct the URL and obscure the fetching. And I know this is kind of crazy history, but like beyond where we ended up, but it was important for me to get there, because when I went back to Solid Start and I started playing with this again, by this time I had met Nikhil Saraf, who was kind of responsible for a lot of stuff in Solid's ecosystem. He did a lot of the heavy lifting on the original Solid Start release, and he also created Vinci, which we used to actually base Solid Start and TanStack Start initially. And he was like, man, Vite is amazing. We don't need to use all this proxy stuff. We can just use a compiler and split these things out, like even in the middle of the files. Like it doesn't matter. He started doing crazy stuff where he was analyzing like things further down the tree and hoisting them automatically and doing like all this stuff. And I'm like, this is crazy. I can't even wrap my head around what's happening. But he's like, look, as long as we have a symbol, like some way of saying like this is a function call, we don't need to use the file system. We can just go like, this is a server function or whatever, and we pass the function to it. And now that function will always be called on the server.
This is where you guys invented Bling, I think you called it back then, right?
Yeah.
Server dollar.
Almost. Bling would come very soon when we brought Tanner in on it. Tanner, I actually presented our original version like this at VConf, the first VConf back in September 2022. And that's when people were like, oh, this is actually kind of cool, because it had types. Like when you start having functions and you can write them like functions where you can just import them, the types match up.
Yeah. And I'll get to that because it brings an interesting point from my perspective about why RPC is so attractive and what changed, because we talked about how the web kind of killed RPC. So it's interesting to talk about how RPC was able to make this kind of comeback. But before we go there, Tanner, I really want to bring you into the conversation finally. So,
I mean, it is basically almost at that point, because Tanner is really into types. So after I demoed this stuff and the type stuff, what came out in the world, that we realized that like what's cool is you can literally write the function as is. You don't, a lot of type things like GraphQL or whatever, you'd have to write these schemas. Where the types inherent off the functions simply from importing them automatically transferred. You didn't have to do anything you wouldn't be doing usually for typing. So once we basically realized that, I started kind of publishing it out there and talking to other people. I was like, man, I still couldn't get over how magical it felt. And then I looked over it quick and I was like, maybe we just need a better symbol. So I was like, let's add a $sign on it. And I actually told the quick guys, like they didn't know I did this. And I was like, I was talking to Manuel at a conference in that fall. And I was like, man, I think Quick could add this. I honestly stole your guys' $sign just because it's like a good indicator. And I'm like, we can just it's just the reverse of what Quick does. Quick is really good at pulling out these little pieces on the client. This is like pulling out these little pieces for the server. It's just like inverse Quick. And they added it to their meta framework within a month after that conversation. Like they were just like, yeah, we already have everything here. And they did it almost immediately. And as I said, that's when Tanner got involved around that point. Oh, actually, it might have been even a little bit later. It was around when Next and React, they were like, saw this stuff too. And they're like, oh, and they came up with like use server, but it was specific for their RPCs for their server function communication.
To be fair, initially they actually had it in the file names, if you recall. They
Yes.
had .server.ts and .client.ts.
That was the catalyst for me right there.
Yeah, I mean, there was like a subtle difference. Like, how should I put it? Because technically, server functions start on the server, and there's like a naming convention where they're like, okay, these are server, these are client, and these are shared. But then like, it's a different scenario because the server stuff can be done all in a single pass, like in a single go. When they originally came up with that was to denote server functions, but not server components, not necessarily server functions, right?
Exactly.
Yeah, or like
they didn't have a notation. Use client came as an alternative to .server and .client in the file names. They didn't have anything for use server, which came around later.
Right, exactly. So they started proposing this stuff. And I mean, yeah, Tanner can jump in at this point, but I think he saw what they were doing and was just like, what the hell is this?
I didn't, I mean, I thought it was neat. I was more interested in like what they were doing under the hood with like the compilation, what was actually happening to the build and transforming the AST and whatnot. But I did not really like the approach to like use client, use server, at least for like RPC. I looked at it and I was excited about like, oh, I can just throw this token in there and all of a sudden I can create an RPC. I'm like, that part's cool. But then all these questions started bubbling up about like, okay, clearly they don't believe that and like configuring an RPC is as simple as a one string. Like that's ridiculous.
So I want to touch that briefly again to give a little bit of context to our listeners. So we talked about the fact that RPC is about invoking a function somewhere else as if it's a local function. And specifically in the context of full stack frameworks, it's basically invoking a server-side function from client-side code using the function called paradigm. So it looks and feels like a function. Now, in order to be able to do that, you kind of need to have, from my perspective, three things. First of all, you need to have type safety. Otherwise, what's the point? And going back to your point, Ryan, about when this appeared, obviously it only came into being after TypeScript really went mainstream, because before TypeScript, the whole typing thing was irrelevant. And the other thing that you need is to be able to simulate blocking. You call to the remote function, you want to have it to feel like a local function, which means you don't get the execution back until that remote function finishes and provides a value. And we only got that after we got a sync await, basically.
Yeah, I mean, I'm native supported promises, but more specific to this conversation, when framework started having tools to deal with async, which took you even longer.
And which brings me back to the final point, is ideally, not necessarily, but ideally, you also want what you mentioned about Vite, the ability to effectively instrument the code. Basically, write something that looks like a function call, identify that this code is going to be running on the client, this code is going to be running on the server, and generate all the magic code that makes this thing work. Basically, it's a stub and on the client and on the server that handles the whole networking layer underneath that function call. Now, I'm mentioning that you don't necessarily have to have it, because TypeScript TRPC does without it. which makes it less magical and also less fun potentially.
Yeah, I
But
mean,
but going back to, I want to give Tanner. I basically stole the mic from Tanner. So Tanner, you said that you looked at that, the fact that they introduced this kind of magic string, and all of a sudden it kind of worked, and you had thoughts about that.
Yeah, because like details matter. Eventually, details matter a lot. Like you, I think what you see is like you write use server in a function, and that's really magical. And it's magical both in a sense of like it's doing a lot under the hood for you. But it's also a magical experience for most like basic operations or basic use cases. It's so simple. It's deceptively simple that it's like, oh, that's all it takes, right? And you put use server in there. But there's so many details that bubble up that you cannot get away from the fact that this is happening over the network. There are implementation details there that matter sometimes.
Caching, for example.
Yeah, caching, protocol, methods, headers, authentication. There's like edge case flexibility that needs to be inherently in the system to allow you to do things that you maybe don't do 90% of the time, but you will need to do. One of the basic ones was use server defaults to a post. Sorry, not defaults. It is a post request in like Next.js and in React Server Component kind of spec, right?
You also don't have any control, like you said, either over the endpoint or the protocol.
No, or headers or anything like that. You can kind of get at some of the implementation, but only at like a global place. But if you wanted to customize any of that other stuff, you can't really do that, and you have to break out of the system entirely. And I didn't like that because immediately I was like, well, I want to use this with React Query. And that's great for caching, but wouldn't it be great if the browser could actually just cache this GET request that I'm making? It's totally capable of doing that. And then there's questions of, well, how is that URL formulated in a way that's going to be stable for the browser to cache? And there's lots of questions that came up for me around that. And I just knew at one point we were going to need to, like, 90% of the time, same experience as just use server. Just create a function, give it some kind of a symbol, a $sign or something that would make it dead easy for a bulk of the use cases. And then have at least the ability or the option to expand and make that configuration advanced. I just don't understand when people create APIs that cannot be ripped away easily or like dug into easily. I don't understand it. And these directives of use server or use cache or whatever are like the biggest offenders of that principle for me. So
it's funny because as you guys may not know, actually, I started with server functions. Solid uses use server today because compatibility with React or like conceptually good there. But yes, wrapper functions are.
So do we, by the way.
Yeah.
Like in TanStack start, you can write use server.
Yeah.
And you'll get the same experience, but it's.
Yeah, like wrapper functions are, as Tanner said, are almost necessary for configuration. Positively at least, is that because this configuration comes from the client, wrapping is definitely something you can do. Like you can compose these kind of pieces on top of server functions because the server parts on the server, the use server, the server $sign represents the split between the, like, this goes on server, this goes on the client. So it is
basically
possible to augment
it. One of the things that kind of enabled, I'll give you in a second, just mentioning that one of the things that enabled this whole thing is, like you mentioned when we talked about Vite, is that smart bundler that's analyzing the code in any event, sees it, and then knows to generate different code for the server and different code for the client from the same source code, right?
Yeah,
That's the source of the magic.
We should talk about Vite here for a little bit more, because the thing is, at this point, Tanner and I are talking, Nikhil, and we're like, every framework could use this. Why just use this only in Solid? Why have, Quick make their own version? Why have Next make their own version? And Tanner was like, okay, let's like just make a generic plugin for this, right? So that's where Bling came about, when it was like, he picked it up and he was like, let's make this generic. The thing that is, Bling didn't quite survive in the same form, because what we realized was Bling was basically like was it a Babel plugin? It was basically a transform. It basically transformed your code without bundler awareness, which does work a lot in the simple cases, but it doesn't work in the more complicated cases. Mainly that how do you register these endpoints, right? Real apps have code splitting. So you might not load all the code in the client, or you might not load all the code on the server. And what ended up happening with just doing a compiler approach was that we would sometimes navigate to a page on the client that hadn't been navigated to on the server, which means the endpoint wouldn't be registered yet.
It didn't exist yet.
So didn't even occur to me.
So like basically this generic approach, it wasn't enough just to stop at Babel and a compiler. We needed something that would actually go through the whole module graph and hoist out these things. And
it had to be bundler.
It had to be bundler level. So that's actually why Bling died. In a sense, Tanner has remade.
It was repurposed.
Right. Yeah.
Actually, what's funny is like a lot of the code from Bling made it into Vinci.
Yes. Yeah. I mean,
at the Vite level, right? And then what's funny is then eventually we ripped it back out.
Right. And the other part of Vinci ended up going directly into Vite when Vite adopted the environments API. Because we were building these things, and the Vite team had, I guess, their own problem with deployment, like to solve with deployment environments. Like you have Cloudflare, which is different than Netlify and Vercel, and you could build for like different outputs, like workers versus pages and all these things. People wanted to have like, and client per server, they wanted to have these different environments. Vinci actually did that because Vite didn't. It was hard to manage these kind of things. And that's why we created it. And in the end, as I said, Vinci now has kind of been dismantled, but the environment API now exists in Vite, very similar actually in usage to how we used to do it in Vinci. And we still have the server functions plugin in the form of what's under TanStack that's now used both by SolidStart and TanStack Start.
Tanner, you're very polite. You raise your hand.
Oh. I was going to say one of your questions went unanswered, and I wanted to answer it before we went too deep into compiler land, and it was about type safety. And that is a massive part of another massive reason of why it all went this direction for me. And it's also because type safety, a lot of people think, well, it's just defining, the types that this function can take on. But in reality, you're not just writing TypeScript types and expecting those to get extracted away into validation, because that's another part where like just treating it like a function still is not totally safe. I mean, I like it that we want to get to this functional syntax of just calling the function and having it be awaited, and it's really nice. But under the hood, it's these details. You need to be aware of them, and one of them is that you're going across the network. So type safety without validation is a complete lie. You validate anytime you go across a serialization boundary, even into the URL or local storage, anywhere. You have to validate, or it's just a lie. So
it's really, I'll let you continue in a second. I'm just clarifying again the terminology. It's that distinction between dev time type safety, maybe even build time type safety, and runtime type safety.
Yeah, static type checking versus actual runtime validation.
And exactly, and TypeScript very intentionally does not do any runtime type checking. So the
Right.
fact that you're leveraging TypeScript types is really cool. You get completion, you get squiggly lines during development, but at runtime over the network, anything might be sent, especially if it's like a public endpoint.
Right. And you might feel like you're just writing a function and it might feel secure, but no one in their right mind would create a REST endpoint straight into their backend and not validate the inputs that they're getting from people. And so same way here, like you want to be validating the inputs going across these functions in a special way that isn't just, oh, it's a TypeScript type, so I'm just going to trust that I'm the only one calling it and that my system's the only one that has access to this public RPC endpoint. Like all of this stuff is easily reverse engineered and abused.
It's even worse because when you're doing posts like straight on RESTful APIs, you know that you're going to have to check the types. You're going to have to effectively cast the types.
Yeah, because you're losing the types purposely going into this protocol and transport mechanism and pulling them back out on the server side. You have to do the same thing coming back out. Otherwise, it's like, well, this is just a blob of whatever, yeah.
And I forget if it was Rich Harris or Liran Tal who literally showed me an example, I think, where they used TypeScript and instead of a certain value passed via RPC being like saying just string, they said it needs to be like the quote unquote quote child or quote teacher. And nothing at runtime validates that some other string is not passed in. So TypeScript literally lies to you in this case if you're not careful.
Right. Which TypeScript needs to come after that, which is it needs to be a byproduct. And that's exactly why we did two things. One, we adopted standard schema. I mean, we helped kind of push standard schema into reality. It was created by all the brilliant people that build these validation libraries,
like Zod.
Like Zod and type, archetype and stuff like that. But we needed validation, so we did validation first. And what's interesting is with our APIs to create RPCs, we do not allow you. I mean, you can do anything you want, but I mean the happy path of our API is that you do not get types in your server functions, in your RPCs, unless you provide validation that gives you those types. If you try, like, we don't have a generic API to just cast the types coming back with just TypeScript because we think it's unsafe. So that is the happy path. You have to use a Zod schema or an archetype schema or whatever to get that validation and turn it into types.
It's funny how full circle this is going. And this happens to me a lot, I have to admit, because looking at this, like the reason that RPC died in the first place was because it was clunky to in my opinion. There's many reasons, but part of it was that it was clunky to define stuff. And like, it's a challenge, like GraphQL going away because, you're defining these like
to define the types and
the schemas. So people did these JSON APIs.
Terrible because of that.
and then people did the JSON APIs and they managed it themselves, but it wasn't schema based. It was through the code at runtime. And then but there's lots of holes there. So now people have reinforced on types, which obviously again gets us back to RPC. But it's funny, the framework author side, let's say deeper on the UI framework side, say guys like myself or people working on React, we're looking at this and we're like, okay, mechanically this works nice. It's ergonomic, it's thing. People can build stuff on top of it if they need to, but I have the pieces I need to do what I need to mechanically, and it's smooth. But then we get to a point where we add back our own friction because of best practices. So that's what I was kind of
we can't have nice things on the web. That's a truism.
So yeah, it's kind of interesting because I mean, I love standard schema. I'm a big fan of Valibot and all that kind of stuff. But it's like one of those things where the people building UI frameworks, usually maybe the meta frameworks can, but the UI frameworks can't generally won't push those kind of things on you because they're
they won't enforce them too hard.
They're not in our range to be enforced because people will have different opinions. Things will change over time.
Too much opinion coming from a framework. Yeah,
right, exactly. So it's like
it's nice being a meta framework because then you get to enforce a little bit more of those opinions.
Yeah, it's just tricky because meta frameworks should in theory have a shorter shelf life because of that. Like this was always the struggle I had when I was working on SolidStar because I didn't want to make a meta framework. I just wanted to make a create React app that worked on the servers. This kind of tension is interesting for the design space. There was something I wanted to say. So you said there's 3 things you need for RPCs to come back.
I mentioned, I'll say it again, maybe it'll jog your memory. Basically, it was a type for the underlying system to be typed or type safe at least at development time. Otherwise, there's no point. So you probably wouldn't do RPC if you've just got JavaScript. As a wait so that you can quote unquote block until that remote function finishes, and optionally the compiler / bundler so that you can automatically generate the stub code to translate that function call into, do the serialization, send the message across the wire, do the deserialization on the other side, and back again.
Right. Yeah. And you just mentioned it twice because I said at the beginning I wasn't trying to build RPC. I think the final piece that actually cemented it for me was the serialization part, because we don't communicate in JSON anymore with these.
You don't?
No. At least
Tanner, I think you do, don't you? The protocol over the wire, is it JSON or is it something else?
For server functions?
Yeah.
Yes.
By default, yes, it's JSON.
Yeah, see, didn't. And this is one of the attractive...
Doesn't have to be, though.
Yeah, this is one of the attractive things for us. You have to understand because you control both sides. So this is like React loved this. We love this. Framework guys love this. This is where you can go back into what Framework wanted is... At the exact same time I was working on this, we were updating our approach to doing streaming SSR and stuff. And we were making it faster and more efficient. Like every framework has their own serializer. Some are publicly available, like Solid Cerevel, Marco's Warp 9, Devalue from Svelte. And we're
going to need to give a little bit more context, I think, at least to some of our listeners about why it is that you need this sort of serialization for SSR.
I think that'll be really useful.
Yeah. Okay. Sorry. Basically, you're sending HTML, which you're like, okay, that's great. But the problem is now you have something async. So you can send the HTML in chunks, let's say. So you're sending, it's streaming is basically the problem. You want to be able to not only send the HTML markup, but you want to be able to send the data across. And if you wait for it all to finish, then just send the JSON and the HTML, then you show the whole page at the end. But if you can send different types of serialization values, it's possible to send pieces of the app in parts, and then for the client to go, you serialized a promise, for example, and the client go, okay, I know this data is coming. That's the most fundamental way of doing it, where we basically describe a promise over the wire. So when it starts hydrating part of the page and the whole page hasn't loaded in from the server, we can go, okay, treat it like a client-side promise. And we know that what will end up happening is actually on the same website page, we'll actually stream that JSON later. But then when it comes in, we'll fulfill the promise on the client. So
again, just to clarify the need, if I understand correctly, and correct me if I'm wrong, it's your HTML is intrinsically streaming. So the HTML protocol, unlike JavaScript, essentially, you can stream it and it'll just execute. The problem, I think, is the order of things, is the fact that that HTML streams top to bottom, whereas you want to be able to stream things and inject them in the middle of things that have already arrived.
Right. Our UI trees
and Tanner has raised his hand again, so I'm going to interrupt us.
I just want to punctuate that and say that it's about order. It's about componentization of these calls to say I have something that needs this amount of data, and and you can have multiples of those. in whatever order you want. And inside of those responses, you can have immediately return partial parts of those responses and have some of them be delayed. So it's almost like you get the same experience inside of HTML where you can give the important stuff really quickly and delay the other stuff. You get that same capability within each request response lifecycle.
You can see it in the
just to say that the joke that I like to say is that the big difference between old websites and modern websites is that we've replaced a single large spinner with a lot of small spinners.
I mean, yeah, we've been trying to solve that. I mean, the challenge is you can see in the shape of the HTML itself, it's XML or it's a markup language. So these things are naturally nested. You see it in your components. You have components and components and components and components. Yeah. So like doing it top to bottom doesn't even work because the outer component hasn't closed. You know what I mean? Like these envelopes. So what ends up happening is the trick to the HTML actually isn't that difficult mechanically, because you can put it on the end in something invisible like a template and have JavaScript move it back into place as it loads. The hard part is the data. If you actually want to wake up parts of that page before it all loads, you need like a placeholder for the data. Essentially, you need to be like, look, this data will be coming, or and
that's a promise.
And that's a promise.
Or a substream.
Right. So we started serializing. Well, I mean, and there's different types of data, right? Like data objects, and different things. So like even stuff like TRPC has like advanced, like super JSON or like advanced data types, but for us, promises were the key and we realized that we could bring that serialization, not just in our original SSR, but use it in our server functions. So we could serialize anything, HTML elements, promises, whatever. And this meant that because RPC let both sides understand. And this is, in a sense, like how server components work in React, because they can go, we have our special JSX on format, and we can communicate both sides. And now we can communicate React components with the wire. As I said, our needs are a little bit simpler with like promises and streams, but it works out kind of similar. It lets us build on really powerful capabilities on this, because you can say, return some data with a promise encoded in it, and then like have the data come back in chunks. You can make an async iterable and basically return a stream. So the server can just keep on yielding data into your server function, and you write it literally as like a async generator function. So you write it as like an async function, and generator where it yields, and it'll literally be yielding from server to client. So there's a lot of really cool mechanics here.
Do you support that I know that Quick supports that. I know that ORPC supports that. Do you guys also support that? The ability to stream a response from an RPC?
Yeah, Solid does.
Yeah, it's in Laravel. I don't know if Solid Start handles it the best in all cases, but the core technology supports it.
So I guess side quest here is we started out building our own serializer. I did for TanStack Start. That was it was a little bit lighter than something like Laravel or the big giant serializer that can do like React server components and stuff. And there's also super JSON. There's even one that the Remix team built, like for React Router.
Somebody on the chat called it Turbo JSON.
Turbo JSON, right? Yeah, there's a couple of these. And I wrote a simple one that would kind of get to MVP for TanStack Start Alpha. And even the simple one could serialize promises and serialize streams. But then we realized that we want to do more complex stuff. We've decided to adopt Laravel. I think I told you that, Ryan, right?
Yeah.
Okay.
Alexis did.
For you. We have one that works for TanStack Start, but we're adopting Laravel because Laravel is beyond just being able to stream this stuff. Laravel has some very unique.
So what is Laravel? I think I missed the explanation.
It's the serializer used by SolidJS, used both in our server rendering and in our server functions. It was built by Alexis Munsek, core team member of SolidJS, and
it's quite.
So it's
unique.
basically serializes stuff over the wire and then deserialize it instead, but it's not exactly JSON, it's something else.
Yeah.
like React doesn't use JSON either, in case people don't know, for their responses from server components.
Yeah.
You see a lot of them that have like it's like a superset of JSON that they then encode and decode special characters, special things. Look for
At the very least, you want command line separated JSON in order to be able to send multiple messages and not be kind of
Right.
stuck on on not closing the bracket or something.
Cerevel is, I think Cerevel is very unique and really cool because Cerevel uses JavaScript essentially to stream. Like to serialize all of this, Cerevel uses JavaScript and streams it and executes it over the wire. And it's incredible to watch it work because even beyond that, I mean, Super JSON has a little bit of this. Yeah, a little bit.
Yeah, yes.
I wouldn't want to call it that, but
yeah, I mean, there is a bit of that, and in some cases where the security is concerned, he's been looking at alternate serialization formats so that you don't have the eval aspect of it. But yeah, it is there's
well,
questions.
with great power comes great responsibility.
But I mean, the power is incredible because this is what enables future facing patterns. We've never had things like single page apps be able to easily do basically picture, people are familiar with React Query, where you can like do a mutation and invalidate like a couple queries. What if you can do the mutation, so send it to the server and have the server figure out what to invalidate, and then while it's still there, start fetching that data on the server and send it back, like return right away from your mutation, but then have it streaming back the data for like the next page you're going to visit, right? If you have the knowledge of, say, like a router and you have this capability of serialization, you can do like single flight mutations and stuff. Oh crap, my computer's going to restart because of
not just single flight mutations, but streamed.
Are we going to lose you, Ryan?
Yeah, for a minute or so. I'll be back. It looks like
I can hold it.
Force update. Yeah,
but
you'll hold the fort.
Yeah, it's not that it's single flight mutations; those have been around forever. But I mean, that's how the web worked anyway. But single flight mutations that are streamed, I think that's the most important part of it. It's like as you get the request on the server and you start processing things that need to change, you don't need to wait to know all of the changes that are going to happen to send them back to the client. You can start processing them and shipping them as you find them to the client. That is incredible. So that your invalidation from the server can essentially be streamed in as soon as you know about it to the client in the same request.
The funny thing, though, is that kind of goes beyond RPC. That's more in the territory of SSR, isn't it?
No, because we're still just talking about individual requests. An RPC, for instance, to say, I want
do a
to
database query maybe, and then
or say I want to update a user. I want to update a user capability, right? I'm adding a capability to a user, and you go to add that capability. On the server side, you'll receive that mutation. You'll create that mutation, and then you're probably going to have a bunch of other things that need to be invalidated for the user or refreshed or streamed to the user that are going to be new. With that new capability, they'll gain access to new items, new things, new collection types inside of their application. And some of those items might take longer for you to fetch on the server and give to them than others. So out of the gate, you'll want to ship them a new user object. That'll be really fast. So you ship that down in the same response. You push that down. And then you're still working on maybe their team data or their workspace data. And then as you get those, you ship those down as well. And so you can start in the same request of just a mutation. The response can contain, immediate and streamed data.
It's really interesting. First of all, you're turning on a lot of light bulbs for me. So thank you for that. And you're raising, and it's interesting because when I'm thinking, I'm old enough to remember the original RPC implementations back in the 90s. And one of the main problems with them was the fact that they were built as being synchronous type operations. And because the assumption was that it is kind of like a function, and function calls usually are cheap. So you can make one function call for the fast stuff and another function call for the slow stuff, or get a callback or stuff like that. And they didn't really accommodate for that scenario that you're describing, where I'm requesting multiple data items and they are available at different times, and that I can create this kind of a sophisticated staggered response that data arrives as soon as it's available, and I don't need to make multiple calls in order to get all this data. Yeah, I'm giving the
Okay.
mic back to you in any
So
event.
I think that it even goes, it takes that even further. Is yes, it works for data that you request that you may know about, but it also works for data that maybe you don't want to know about, but needs to be sent. Is it leaves room now for this hidden layer of metadata, of meta actions or meta code that could happen with a request response. So for example, the developer experience that I would want as a developer, when I say update this user capability, I just want to update that user capability. I don't want to have to be responsible for receiving and acting on all of this extra data coming back to me, though. I just want to trust that it's going to work. And so naturally, what a lot of people would say is that say, well, I'm going to update this user with a new capability, and then they get it back. And what do they expect? They expect the response to be a user, the new version of the user that has the updated capability. What they're not going to expect is to have a bunch of other random, data invalidation payloads that they now have to handle. So what's nice about something like Serial is that it's not just, this super set of JSON or whatever, but it's the ability for even frameworks or middlewares or things in the middle of that operation. More code can just be sent down to the client to execute that the response doesn't even need to handle or know about. So it leaves a lot of room for optimizations and frameworks to get into this request response lifecycle, but still keep the developer experience really lean, not needing to
Lean, but a
worry
little
about.
bit scary, because if I'm understanding correctly, what you're saying is, let's say I want to get the new user, an updated user object from the server. So I do an RPC call, I get back the new user, and I do with it whatever I do with it. But it turns out that it also realized that some group that the user belongs to updated. So it sends that down as well. I don't handle it because I don't expect it. So I didn't even write the code to handle it, but it also sent the code that will handle it for me, if I understand correctly what you're kind of
It
saying.
depends. It depends. A lot of this gets into how you use such a tool, right? Yes, you could stream down the code that handles it as well, but more than likely, that kind of code would live on the client. It would live on the client side to say we are orchestrating this metadata layer, right? As the client, we know that we are going to want this extra metadata to invalidate.
So it's a callback that I attach, that one, or middleware that I attach, that gets invoked with the extra data that happened to arrive on because of some other call that caused it to be sent.
And we're talking about middleware that can span the client and the server, just like a server function, right? It's middleware that can compose together inside of this system that's extracting into client and server and creating its RPC middleware, essentially what it is.
Correct. I'm trying to think of an actual valid scenario, and you tell me if it kind of matches.
Sure.
So I know that a lot of times secure systems have this concept of a refresh token. So if your access token invalidates, you have a refresh token that generates a new access token for you. And that happens behind the scenes. You don't need to be aware of this whole thing, or this whole mechanism going on. So is it something kind of like that?
I don't know if I would use this for that. I mean, you could.
No, I'm just thinking about a scenario where you're making a function call for A, but that triggers also other stuff to take place in the system that you may not necessarily be aware of.
Yeah, I think what we're mostly talking about here is optimizations, right? Kind of like the example that Ryan brought up is like you send off a request.
Pre-caching?
Yeah, you send off a
pre-caching?
request with a mutation, and the intent is known that you're going to be at this destination next. Instead of waiting for all of this to settle, the dust to settle before you go request the assets for your next destination, you can do all of this in one request. You can send all of the assets that are going to be requested anyway.
Yeah, it's kind of interesting.
Kind of like resource hints in a sense.
Yeah, what I found kind of interesting about this approach,
Resource pushing,
yeah.
When I was working on the solution was the kind of that realization is that people are already writing their code mostly isomorphically, which means that like they're already creating these patterns. So like running the route loaders again on the server and a mutation, and then expecting the code to be basically the same on the client because it is the same code, it's source code, basically gives you this ability. So like what was kind of cool is the kind of optimization levels you can go in, because if you're in a nested route, if you're familiar with nested routing, maybe the top section doesn't change, only the two sections underneath swap on this navigation. So you're staying on the same main page and then you go to the next page. Well, if that data from the top main page isn't being updated, then you don't have to fetch it again on the server loaders. Like basically we were able to use the same sort of knowledge of what route changes and what data is already available based on what things it would fetch when it navigates to those pages, to the point that we basically go, okay, this is already there and the client don't need to update it and it hasn't been explicitly invalidated. This is already there. This is new. This isn't just on this page. This has been updated. And then fetch those things and put them on that request. But the client or the server responds right away. So the server goes, okay, we're going to redirect to this next page. And the client goes, okay, I'm going to go to this next page. So the client goes to that next page. But because those promise stubs are there, when it goes to load the data, it goes, oh no, promise stub right here. It's already in the cache. I'm going to use this promise instead of fetching it again for the stuff that's new. So it's kind of, it's weird how you can kind of like do this kind of predictively, but in the end, what you end up with, which is my favorite part about this, is you're actually leveraging your knowledge of the client-side cache on the server here. So you actually don't need caching on the server in this mechanism. Like you could still optimize it with like a Redis or something, but we never went through that whole Next.js use cache dilemma or cache stuff, because when you do server functions, you re-render the whole page. It's kind of like Remix. It's like that loader bit, the whole route sections. So when you hit and you have 5 data points, well, guess what? You are fetching all 5 data points. There's no way for you to separate those apart, which means that if you don't want to refetch all 5 data points every single time, you are going to cache them on the server. Where this approach, it lets you basically use the knowledge of the route and the knowledge of the invalidation from the mutation to actually only fetch what's needed. So server caches aren't necessary. It feels like a single page app where, the cache is on the client, but it's actually doing this all in a single
So
request.
again, let me see if I'm getting this, because to an extent, it's kind of incidental to the fact that it's RPC. It's basically the fact that you're controlling both sides and the protocol that lets you do a lot of magic. The fact that it's RPC, like I said, is almost incidental. It might have been some other mechanism. But what you're saying is this: I'm triggering an operation to receive data. I know that this operation will likely trigger a redirection or a transition to another page. I can prefetch or push more accurately. I can, like you said, Tanner, I used the wrong analogy because it's not client instigated, it's server instigated. The server side knows that I'm likely going to be needing that additional data. I can send it down, hold it somewhere in the client side, so that when I actually need it, it's already there, basically.
And that becomes even more powerful as you stream, because we could do this before with single flight mutation is you send it. And if you spend enough time on the server, you can gather up all of the data and finally send it all back and then allow the user to navigate. But streaming allows you to respond immediately, but kick off those requests server side and then stream them down to the user.
Right.
And utilize that connection that's already open.
It's because the frameworks support async natively. Things like suspense basically will trigger and treat your cached promise or your pre-pushed promise and a new promise it would fetch identically. So in these kind of scenarios, you actually get further ahead. You can start rendering the next page before that data has arrived.
And the fact that we're componentized kind of necessitates this whole thing, because otherwise, one of the big problem with components is that encapsulation, if you're following through on it, often leads to waterfalls. So the fact and React query back at the time was so great in this regard, because you fetched from one component and then it got reused the data in other components without you needing to like break encapsulation and be very explicit about it. It was totally implicit. So now you're kind of taking it to the next level in a sense.
This opens up a new can of worms. I don't know how deeply we want to get into that, but
Can always have you on again.
Component level data fetching, I think it's still really the way to go. And then thinking about the optimizations that need to be made at the routing level and the SEO level and the page levels to get rid of waterfalls. And these are optimizations, and making those optimizations as easy as we can is really important. And we can do that through API design with our routing. We could do it through compilers like Relay. But they are optimizations, I think, at that point. I like this. I like everything that we've talked about is really exciting.
I'll interrupt you again, because I have to say that one of the biggest downfalls of RPC back in the old days, and one that I was so concerned with that I actually, at the end of my presentation on RPC, I talk about the potential downsides of RPC, and it's one of the items listed there, is the fact that RPC kind of encourages waterfalls, because you make a function call to get some data, and then you make another function call to get some more data, and another function call to get some more data. So you end up with chatty protocols and waterfalls, because the implicit assumption is that it works like functions, and functions are cheap. And what you're saying is that you're overcoming it by being smart, realizing, you can still write it like it is if it's a waterfall, but you've triggered the request, the generation of the code that's going to be requested in the third request in the first request, and I've already maybe even sent it down. So by the time I get to that third RPC call, it's returning immediately because all the data is already there.
Yeah, we're getting into what I would call orchestration of RPC, like RPC orchestration, because and I think that single flight mutations is one kind of flavor of utilizing RPCs and orchestrating like data flow through RPCs. There's other ones like routing is a big RPC orchestrator. Really, anything that's providing lifecycle based on user input. So even forms or the framework itself.
It's tricky, because the biggest cause of waterfalls, in my opinion, in terms of co-location, is often there's two causes. There's the code splitting. We want to code split at the route level generally. Like, you can do lazy components wherever, but because of the code splitting, it's hard to fetch the data before you have the code to fetch the data, essentially. So that's what pushes us to hoisting. And it's necessary because you don't want to load all the JavaScript for your whole app. But if you didn't actually do that, then the second thing you hit on the client is that co-location of UI and components can lead to waterfalls depending on how the renderer handles the async in the rendering. So, like, for example, let's say every time you hit a promise you throw, and it then re-renders the whole thing. Well, if there's a promise after that, well, then you're causing a waterfall, right?
And I'm saying that because RPC potentially brings in a third cause, which is just the fact that people look at the code, think that if it looks like a function, then it is a function, and just write the code in a way that's very inefficient and generates a waterfall regardless of the framework.
Right. Which is well, I mean, there's two different types of waterfalls: necessary waterfalls and unnecessary waterfalls. Necessary waterfalls can still be made unnecessary if you say move everything into a single function call and put them together,
Right.
whatever.
But
there's a dependency. But there's a dependency, right? Like there's you need to get the users to get or get the user to get the post for some reason. But if you could fetch them both off the user ID, like the post for this user ID and the user information off the user ID, then that's an unnecessary waterfall. The problem is we cause unnecessary waterfalls all the time in our UI rendering if because we go, okay, well, the posts go under the user section, and then you basically by using async in your component, you're basically putting in a wait in the middle and blocking rendering sucks. So waits suck for rendering UI. You don't want async components really. React gets away with it on the server because it's on the server and server waterfalls are not as bad, but I'd argue against that. I generally speaking, it's this co-location of data and UI that causes this blocking. The reason I'm stressing on this is because it's solvable with signals. Basically, if you're doing fine-grained rendering, there's no reason to await or block except for where the data is finally being used at the end of the data chain, which means that you could parallelize this data fetching for unnecessary waterfalls, not only for sibling components, but also nested components, because the component aspect doesn't matter. You're not blocking to re-render this component. You're literally just going, oh, I actually need this in this text in this div. I'm going to block there, and everything beside it's a sibling. You basically you flatten the whole tree. And this is something I noticed.
And just to be clear, you do all this magic for us automatically, right? It's not something.
This is run time, what I'm talking about. The funniest thing is it's not actually magic. It's just the way signals work. This is something that I kind of discovered a while ago when I was doing fine-grained rendering, that fine-grained rendering is actually, it flattens the tree. That's basically what it does. There's no components anymore. You just have a bunch of independent things. So if you flatten the tree...
Because signals don't care about component boundaries, essentially.
Right. So if you flatten the tree and talk about it async that way, then it's the same thing. Nothing has to block unless it actually has a data dependency on itself. So necessary waterfalls still block, but things that are not necessary waterfalls don't need to block. So I think this is another win that you're going to see in the signals library. So people haven't really been leveraging this yet, but it's coming soon, and we know what it looks like.
Right. So I'm going to jump in here because we're running a little long here on time. And I have a suspicion with anything that Dan gets into, we could talk for 2 or 3 hours when he gets into a topic. So before we wrap up and head to picks, is there any last words on RPCs in summary?
All I can say is my summary is that we absolutely positively need to get Ryan and Tanner on to continue this conversation, because we are scratching the surface, it feels to me.
Yeah. I mean, even just what Ryan brought up about all the async signal stuff, there's a lot that we could go into.
Yeah, but TanStack is built on React. What does that have to do with async signals?
Maybe you say something about that.
Let's save it for later. Let's save that for later. We are running long. There's a lot to talk about, but and you hold on. You brought up a good point though, about the necessary waterfalls as well. Necessary waterfalls are still there and they still need to be handled. And I feel like I've been spending a lot of time on that as well. As you can still make mistakes there that you can't solve with a bundler, or you can't solve with signals or anything like that. So, but you can solve some of those problems with good API design and prefetching and so I think there's a lot more to unpack there. I don't really want to. Okay, there's a reason that TanStack everything is built to be agnostic. I'm a very firm believer in React, and obviously it's our most supported framework. But it's by no means perfect. It's not. But it's amazing. It's great. there's pros and cons to every UI framework, but I'm very much preparing for a future where there are bigger, better UI frameworks doing amazing things. And the things that Ryan just teased and talking about with like signals and async and flattening signals to around suspense and things like that. That stuff's really exciting. I'm just going to gush a little bit right here before we end and say that the things that Ryan is working on with Solid 2.0 have made me the most excited about what's technically possible with a UI framework since I discovered React and discovered hooks and really got into it. So hopefully it's a good teaser for maybe what we can talk about next time.
Thanks.
Yeah. Look, I'm here for it each and every time. You just say when, I'll have you on the show again.
All righty. Well, thanks to Ryan and Tanner for scratching the surface on our RPCs and wetting our whistle for more discussion on the truly geeky stuff that we talk about. With that, we'll move to picks. Picks are the part of the show where we get to talk about anything we want to talk about. It could be tech related, could be not tech related. We run the gamut. I will start off with what I consider the high point of any of our episodes, which is the dad jokes of the week. So the other day I was watching a show called 10 Ways to Avoid a Shark Attack. And I was surprised that Stay Out of the Water wasn't on the list.
There was actually a skit about that on YouTube where they do a parody of a horror movie when there's a shark in the pool, and everybody's like, "Oh my God, there's a shark in the pool! What can we do?" And the one guy keeps on saying, "Just don't go into the pool."
Right.
So, yeah.
My drum joke here is not working, and I'm really bummed, because that adds all the impact. So I'm going to have to sue Riverside for that one. So my wife looked at my feet this morning and said, "Honey, your socks don't match." And I said, "That's funny. I have another pair just like them in the drawer." Boom. And then finally, in a surprising announcement, Head Shoulders have decided to discontinue their popular anti-dandruff shampoo line. The decision left many people scratching their heads.
Unexpected.
Not that I need that, as you can tell by the video. So those are the dad jokes of the week. Dan, you got any picks for us?
Yeah, so two funny things. First of all, Avishai Shalom, who we've had on this show a while back, made an interesting observation on X, and I'll literally quote him because he just wrote it very well. He was talking about the fact that will AI destroy the World Wide Web because it's destroying the web's business model. And he says it's actually worse. LLMs mark the end of open networks because the cost of producing junk and malicious content is now near zero. We already see this in LinkedIn, Facebook, etc., but more alarming in GitHub and NPM. And it's a very interesting observation, I think. And so that would be my first pick, that observation. And the second one is this funny story that just came out about the fact that the UK government is trying to sue 4chan. Turns out that the UK passed a law that requires age verification before you access potentially offensive content. And 4chan, being an American company, is not complying with UK laws. So they're actually trying to force them to comply they sent them a threatening email, and they basically responded with First Amendment, bitches. And it will be interesting to see where this goes. So yeah, that would be my second pick. And I think you can tell which side I'm on in this argument. Or put it this way, the worst thing that has ever happened to the web, I think, is GDPR.
Yes.
And yeah, we don't need any more of that. So yeah, those would be my two picks for today.
All right, Tanner, you got any picks for us?
Picks. How random are these picks? Do these picks need to be?
The randomer, the better.
Yes.
The randomer, the better. Oh, okay.
While you think about it, we'll go to Ryan, see if Ryan has anything.
Let's hear it, Ryan.
I'm just trying to think here because I've been so busy. If you guys don't know, I have a little baby at home, so
That's your pick.
Yeah, I mean,
Yeah.
I mean, honestly, I don't get to watch or check out nearly as much as I want to. That and like kids shows. I recently watched, what was it, K-pop Demon Hunters.
I've heard good things about that one.
Yeah,
actually.
you know, I mean, people are going to disagree with me, but it gave me like, it's got almost like Sailor Moon vibes, but like a big production, thing. It was fun. The kids liked it.
Yeah.
Since you mentioned the show, and to give Tanner a little bit more time, I have to say that I was really disappointed with the second season of Sandman. I mean, they had an entire episode which was literally a funeral. I mean, what the F?
I haven't watched that one, so I can't
I-
contribute.
Oh, I know. I know what else I want to say without giving away too much. I actually enjoyed the ending of season 3 of Squid Games. They shouldn't have split it, but
Really?
But I like the second and third season together. It ended in I like the way it ended. So maybe I'm going to be minority, but I actually, if you're willing to watch the second season, you should finish it with the third season. But,
Well,
yeah, my
I
son
guess
was really into that one, and he was explaining the plot to me. I haven't watched any of it, but he was explaining to me, and I mean, it sounded, the first season is just creeped me out. It was more of a Hunger Games type vibe, and it just sort of creeped me out. But he was explaining what was going on in the second and third seasons to me, and that's pretty intriguing the way they're doing it.
Ryan, I'll take your word for it as long as you don't tell me that you enjoyed the 8th season of Game of Thrones.
no, that was not my favorite.
All right, Tanner, we gave you some time. What do you got?
I mean, I like Ryan. I don't consume a whole lot of what's out there. I'm more of a builder, but there are a few things that I do enjoy. So I'm overly hyped for the new season of Stranger Things coming out. And so we've been rewatching all of the seasons before it. So that means that I've seen the first season 4 times, the second season 3, so on and so forth. And we're watching the 4th season for the second time now. And then we're going to anxiously await number 5.
Yeah,
And
that's an interesting argument that I had with AJ about fantasy book series that tend to come, not yet finished, and then the next book comes 3 years after the previous book, and you don't remember anything. And I never have it in me to reread those previous books. So you do have it in you to rewatch the entire series.
They were so good, and Stranger Things connoisseurs will tell you, well, this season was worse and this season was terrible, and but like going back and watching them, I mean, it's been a long time since the first one came out, so like I'm very much more adult now than I was then watching them, and just the acting from these kids is just incredible. It really is so good. And the writing for how quick they were taking out the first couple of seasons, like the writing in some places I was like, okay, like that could have been better. But for the most part, we're just spoiled with great content. Like what a fun story, a great story. And yeah, I was just telling my wife, season 4 got a little dicey because it started feeling really evil. And I was like, man, I don't know if I want to take part in this anymore. And then all of a sudden it went super sci-fi. And I was like, okay, this is awesome. So yeah, we've been watching Stranger Things, and that's about the only like one episode a night, and then I'm asleep. So that's about the amount of time that I have to consume.
How old are your kids, if I might ask?
I have a 7-year-old, a 4-year-old, and a almost 2-year-old. So,
well, I'm
You're
not
busy.
surprised then.
They're not watching Stranger Things right now. The sick for them is I just introduced them to Spy Kids.
Oh wow!
And they are like, this is the coolest series ever made. So they're living in a different world right now that's just as cool, but way more child friendly.
No, I was asking from the perspective of your free time because, like Ryan said, then you have little children at home.
Yeah, we both have little children, and I know from talking to Ryan that they happily consume a lot of our time. So yeah, it's basically at night for maybe an hour that we get to indulge in something. So
all I can say though, from watching from the other side, as it were, enjoy it while it lasts.
Yes.
Oh yeah, for sure.
Yeah, mine are 25, about to get married, 22, and
Congratulations.
14. And so, yeah, we have a little
Excellent.
more free time. But yeah, I miss some of those. I'm looking forward to grandkids and be able to have the kids and then say, here you go.
Yeah.
Well, my baby girl is 23 years old, working in tech.
Very cool.
Yeah.
So, all right. So with that, we're going to wrap this up, and hopefully we'll have these two back again to continue our discussion. In the meantime, thanks for watching / listening, and we'll talk at you next time.
Bye.